Hey, this is Chris, and we are looking at question 31 here in section 4 of SAT Practice Test 3. So for this question, it says tickets for a school talent show cost $2 for students and $3 for adults. If Chris, hey, that's me, spends at least $11 but no more than $14 on X student tickets and one adult ticket, what is one possible value of X? Okay, so the equation here that we would put together, if it's $2 per student and $3 per adult ticket, they tell us X represents the student ticket. So that would be 2X, and then plus 3 times the number of adult tickets, and they specify that that has to be one ticket. So we can plug that in as 3 times 1 for that. And then they give us a range here of values, at least 10, which means greater than or equal to, I said 10, sorry, 11. At least 11 means greater than or equal to 11. And then no more than 14 means less than or equal to 14. So we have a range of values here. This is something we refer to as a compound inequality. And we can solve both sides separately. So you can treat it as if it's two separate inequalities. And sometimes with these, it makes it a little easier actually to write it out as if it is two separate equations. We have 11 is less than or equal to 2x plus 3, and we have 2x plus 3 is less than or equal to 14. And when we solve for x, we subtract 3 on both sides. So we get 8 is less than or equal to 2x, and 4 is less than or equal to x. And then for the other side of things, we do minus 3 on both sides. 2x is less than or equal to 11, and x is less than or equal to 5.5, which means that for this, any appropriate value, and they do say one possible value, which lets us know that there could be more than one solution. So we can't use decimals here because x represents a number of tickets, and you can't sell a fraction of a ticket. So here you could plug in 4 or 5 as a possible answer and get credit on this grid in for number 31. Now let's take a look at number 32. And we have a table of values here for president ages for the first 12 presidents of the United States. And it says in the question, the table above lists the ages of the first 12 United States presidents when they began their terms in office. According to the table, what was the mean age of these presidents? And so here, when they say mean, that just means average. And to find the average, you're going to take the sum of terms divided by the number of terms. So let's take the sum, and we would add up all of these values. So plus, 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 all the way through here. I'm going to add these all up. And when we add those all up, let's see what that comes out to. Plus, 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 plus. So I'm going to put a bunch of pluses around so we know that we're adding them all, summing all these terms together. So luckily, this is section 4, which is calculator section. We can go ahead and add it up. 57 plus 62 plus 58 plus another 58 plus 59 plus 58 plus 62 plus 55 plus 68 plus 51 plus 50 plus 65. So that total altogether for all those ages is 703. And then since it is our sum of terms divided by our number of terms, we could count them off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But generally speaking, SAT will actually give you that number of terms somewhere in the text description of the scenario. In this case, they tell us it's 12, so we don't even have to worry about counting it. We can use that. 703 divided by 12 will give us 58.583 repeating. So let's talk about what we would actually grid in, because they want us to round your answer to the nearest tenth. So they're going to tell you how many decimal places to round to. And here, that would be one decimal place. 58 point, since this number 8 is greater than 5 or greater than or equal to 5, that means we round up. This would be 58.6 that we grid in for our correct answer choice here on number 32. Now for 33. If the expression above is rewritten in the form ax squared plus bx plus c, where a, b, and c are constants. What is the value of b? So a lot of times on this question, I'll work with students who read the question and then immediately say, oh, I'm not sure what they're talking about. I don't know what to do. And they'll get a little stuck, which is okay. But the solution to that oftentimes is, even before looking at the text, when you see the expression given, what would be your first instinct? And sometimes it's okay to go with that instinct. I think a lot of test takers get thrown off by the wording in some of these questions. So if we can avoid getting distracted by the wording and just use our instincts, if this were written on a page with nothing else, no text description, and I said, hey, what would you do? A lot of test takers would do the right thing, which is see if you can simplify this and distribute this coefficient from that second parenthesis, see if you could combine like terms and make this a little simpler. So let's try that. Here we have negative 3x squared plus 5x minus 2. And then if we distribute that negative 2 to each term within that parentheses, this would be negative 2x squared plus 4x plus 2. Now we can combine like terms. Negative 3x squared and negative 2x squared gives us negative 5x squared. Positive 5x and positive 4x gives us positive 9x. And negative 2 and positive 2, those actually cancel out. So we're left with negative 5x squared plus 9x, and that's going to match this format. So if it's helpful, you could always write in a plus 0 on the end for that constant. And sometimes people like doing that visually because it just makes it a little bit easier to assign values for a as negative 5, the coefficient on your x squared term, b as positive 9, the coefficient on your x term, and in this case c, our constant, equals 0. And that gives us all the values we would need for whatever the question happens to be asking. In this question, they want to know the value of b, and we can see here that b equals 9, so that's what we would bubble in for our correct answer for 33. Let's take a look at 34. In a circle with center O, so let's draw a circle. Let's give it a center point O. It says angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by central angle AOB is what fraction of the area of the circle. So basically this is a part over whole relationship. When they say what fraction of, we want to interpret that as part over whole. And we're talking about radians. And when you see radians, when you see this keyword here, radians will always be measured out of 2 pi. So think of a unit circle, and if you've taken pre-calc, we know you're very familiar with this. If you haven't yet, a unit circle is just a circle where the radius is 1. So if you think of a circle with a radius of 1, then the entire circumference, that total, all the way around, circumference equals 2 pi r. And if the radius is 1, then that's like saying the circumference, or the whole radian measure. Radian is just a measurement of length. It's kind of like degrees are measured out of 360 for a circle. Radian will be measured out of 2 pi. So when they ask you about this fraction, they're really just saying that this is your part, the 5 pi over 4, and this is your whole, the 2 pi. So they want to know what portion of the circle, this angle here from AOB. So they're asking about this particular measure here, what portion of our total. And like we said, as long as we can understand that the 5 pi over 4 is our part radian relationship and the 2 pi is our whole radian relationship, then we're really doing, for this question, 5 pi over 4 divided by 2 pi. And to make it easier, whenever you're dividing by a fraction, sometimes it's helpful to make it look like a fraction. This is really 5 pi over 4 divided by 2 pi over 1. And that's the same if you do keep, change, flip. It's always the same as multiplying by the reciprocal. Here you can cross cancel your pi's, multiply straight across, and we get 5 over 8 as our part over whole relationship for question 34. So if we didn't know what radian measures are are always going to be out of 2 pi, and that's kind of like what you might see with your angles. Actually, I'll color code this a little bit, but here you've probably seen before where you have a part over whole relationship with an unknown central angle compared to your total degree measure. And so that degree measure is going to be out of 360, and your radian measure is going to be out of 2 pi. Those both are representative of this same part over whole relationship that we're being asked for here in 34.